Hello and welcome to section 2.3, real zeros of polynomial functions. And in this section we're going to do a little bit to find the zeros of these functions. And so first of all we're just going to practice some problems along the way that will help us get towards the actual solutions we want. So the first one we have up here is they want to use long division to divide this problem. So we're going to take x plus 3 and divide it into this. So x plus 3 is going to go into x to the fourth minus 10x squared minus 2x plus 4. And so if I'm going to use long division, I only concern myself as I'm doing this is how can I make this guy, the x, look like the first term I'm dealing with. So how do I make x look like x to the fourth? Well, I have to multiply by x cubed. So if I take x cubed and multiply it by x, I get x to the fourth. And if I take x cubed and I distribute now the x cubed to both of these terms, and so the x cubed to the 3, I get positive 3x cubed. Now you'll notice that this doesn't work out because I have an x squared. So what I neglected to do was to put in any missing x terms. So I'm going to have to erase this part and add in a 0 x cubed term minus 10x squared minus 2x. So if you're missing any x terms, if it counts down from 4 down to 0, or to 1 in this case, then you have to add in any missing terms. So now I have my correct term, so x cubed times 3 will give me 3x cubed. Now I can subtract the bottom row from the top. And when I do this, I don't really think of it as subtraction. I try to do it as addition. But what I do is I change the signs on the bottom row, and then I can add straight down. You'll notice that if I add the first terms down, I'll get nothing, and they become 0. So the whole goal is to get rid of that first term, and that's why I am trying to figure out what will make this first x term look like that guy, match it. And so when I add straight down, I have a negative 3x cubed minus 10x squared. And so now my goal, again, is to make this x, the x out front here, look like a negative 3x cubed. The only way I can do that is to make it multiply by negative 3x squared. So if I do that, negative 3x squared times x is negative 3x cubed. I do my distributive property, and negative 3x squared times positive 3x would be a negative 9x squared. So you'll see that my powers match up, so that's good. And now I'm going to go ahead and subtract the bottom row from the top. And so that means changing the signs on the bottom row. And if I add straight down, you'll notice my x cubes go away. Here I'm left with 1x squared, a negative x squared. And then I'll bring down my next row, which is a negative 2x. And so hold on a second here. I'm going to kind of shrink this down a little bit. And so I get something that looks like this, give myself a little more room. I'm still concerning myself only with that x term, and so I need to figure out how I'm going to make x look like negative x squared. Well, that would be multiplying by x. And multiplying by x, I get negative x squared. Multiplying positive 3 by negative x, distributing, I get negative 3x. If I change my signs on the bottom row to their opposites, and add straight down, I'm left with x plus 4. Well, the only way I can make the x look like an x is to multiply by 1. So that would give me x plus 3. And you'll notice that when I change my signs on the bottom row, not everything is going to go away. I'm actually going to be left with 1, with a term of 1. Well, that is my remainder. And so how I write my remainder is, my final answer for this is, after doing this division, is x cubed minus 3x squared minus x plus 1. And the remainder that I got was 1, so it's positive. So I'm going to add that 1 on, but I have to remember that it's actually being divided by the x plus 3. And so that is the answer that I'm looking for by using long division. Now, the one down here, I'm going to use synthetic division, which is a little less of a process. But the issue with synthetic division, it only works when you are dividing by a binomial, a 2-term, x minus 2. If I was dividing by x squared plus 3x plus 2 into this guy over here, I cannot do synthetic division. So just know that long division will work for everything. Synthetic division only works for when you're dividing by a binomial x minus 2. So the setup for synthetic division is that I solve this x minus 2, I set it equal to 0, and so x will equal 2 when I add the 2 across the equal sign. So that's the number, the 2 goes in the box out front. All the rest of these guys, the coefficients, the leading coefficients of each one of these terms, the 2, the 7, the negative 4, keep the signs, negative 27, and negative 18 will be written across. If I was missing a term like I did up above up here, then I would have to put in a 0 to hold its place. So, but since I'm not missing any terms, I can write it out as 2, just the leading coefficients, 7, negative 4, negative 27, and negative 18. And I'll go back and do the first one with synthetic division just to show you that I get the same answer for that one so you can see it as an example. Now I draw a line down here and I put a little line right here because this area over here is any remainder that I get. So whatever I get here is a remainder. If it's a 0, then x minus 2 divides evenly into this polynomial up here. So first thing you always do is you just bring down your 2. The first term, whatever the first term is. So that's a 2 in this case, so I just bring it down. I multiply the 2 times the 2, the bottom term down here, and I get 4. I'll add straight down, which gives me 11. Multiply by 2, which gives me 22. Add straight down, gives me 18. Multiply by 2 again, I get 36. Add straight down, negative 9. 2 multiply 2 by negative 9, I get negative 18, and in this case looks like negative 36 is my remainder. So this x minus 2 doesn't go in evenly, and what I basically have done is by doing synthetic division here, I have reduced all of the powers, the 4, the 3, the 2, the 1, and the 0 x powers by 1. So if I was writing this, I would say, oh, well, this is an x cubed term now. This is an x squared term, this is an x term, this is a constant, and my remainder is the number divided by my original divisor of x minus 2. So I could write my final answer as 2x cubed plus 11x squared plus 18x minus 9 minus 36 over x minus 2. And so that is the synthetic division of this problem. So let's go back and try synthetic division because sometimes we don't remember how to do this. And so I'm going to erase this long division part. And since I'm dividing a binomial into this, then I can do synthetic division. So remember, I start with x plus 3 equals 0, so x equals negative 3. And by doing this, basically, by changing the sign on the number that you're using, you're basically doing long division instead of, when you add, you're really subtracting because you're using the opposite of the number that goes in there. So there is a relationship between long division and synthetic division. That's the reason why you can use either when you're dividing by a binomial. But again, this trinomial dividing by a trinomial is a major problem. Okay, so that's why long division is the way you should do this. But I'll show you synthetic division on this one. Now remember that I was missing the cube term, so that was 0, and then negative 10, negative 2, and positive 4. And I draw my line. This guy down here, I draw my line between the negative 2 and the 4, which will show me that's where my remainder is. And if this works out, it should be a 1, because that's what we got before. So bring down the first term. Multiply by negative 3, and then add straight down negative 3. Multiply by negative 3 again, get positive 9. Add straight down, you get negative 1. Multiply by negative 3, negative 1 by negative 3, I get 3. Add straight down, I get 1. Multiply negative 3 times 1 gives me negative 3. There's my remainder of 1. So I have my x cubed term right here, x cubed minus 3x squared minus x plus 1 with a remainder of 1 over x plus 3. So it's the same thing, and if you have your notes from the long division, look back at these numbers right here and you will see these numbers in your long division as you're working through it and as we did it. So there is a relationship between these guys. So remember, if you have questions on these, please come to class prepared to ask them. And then, so then we have a remainder theorem, and it says if using long division or synthetic division there is a remainder, this number represents the value of the function for the divisor. So the remainder theorem is basically saying that we could plug in an x value and find out if there was a remainder. And so if we want to use long division or synthetic division to evaluate this, I could plug in -2 and find out if I get 0, then -2 is a factor, is a solution, is a 0, a root of this problem. But if I get something other than 0, then -2 is not a root of this problem. And so I will do it with long division and synthetic division just to show you how this both works. Well, if I'm using the way this is set up, synthetic division would be the quicker way of going about it because I've already solved for x. So I would say -2 and then 3, just make sure I have all my powers. I have a power of 3, 2, 1, and 0 on my x's, so I'm good. So I could say 3, 8, 5, and -7. And then I would set it up. I'm going to leave it like this because I'm going to come over here and do long division. So that would mean I'd add the 2 across the equal sign so that x would equal 0. So x plus 2 equals 0. And so x plus 2 will be divided into this thing of 3x cubed plus 8x squared plus 5x minus 7. And so now I'm going to make my x look like 3x cubed, which would be 3x squared. So 3x squared is going to be distributed to both of these terms. So 3x cubed and 6x squared. Change the signs on the bottom row before I add them together and add straight down. The 3x cubes go away. I'm left with 2x squared, and then I bring down my positive 5x. I will then figure out how I'm going to make this x out front here look like the 2x squared, and that would be my multiplying by 2x. So 2x squared, and then I get positive 4x. So if I change the signs on my bottom row to their opposites and add straight down, the 2x squareds go away, and then I'm left with just an x. And so then I get minus 7 when I bring down that -7 term. And so then I got to make this x look like that one, which is just a multiplying by 1. So I add a 1 up here. And so that gives me x plus 2. And when I change the signs on the bottom row, I get -9 as my remainder. So my final answer for this problem should be 3x squared plus 2x plus 1 minus 9 over what I divided by x plus 2. So hopefully using synthetic division I'll get the same thing. And so remember, with synthetic division you bring down your first term and just write it down there. Multiply -2 times 3, which will get you -6. Add straight down, that will give you a positive 2. Multiply -2 times 2, you get -4. Add straight down, you'll end up with positive 1, and -2 times 1 is -2, and add straight down, you'll get -9 as your remainder. So you can see there's my 3x squared plus 2x plus 1 minus 9 divided by x plus 2. So I get the same thing either way. Now, using the remainder theorem, how could I have done this without, could I find out if -2 was a factor without doing all of this work? Yes, I could have. Because basically, the remainder theorem says if I put -2 in for x and get a number other than 0, this does not go in evenly, and so then if I needed to find out what it was, I could go ahead and do that. But so I'm just going to write this out. -2 cubed is -8. So -8 times 3, I believe, is -24. -2 squared is 4. 4 times 8 is 32. -2 times 5 is -10. So I'll just put subtract 10. Subtract 10 and subtract 7. So if I combine these guys, it looks like I got -34 when I combine the -24 and the -10. So that's -2 and -7 gives me -9. So the remainder theorem says if I plug in one of my terms, what I think is a factor, into the function, I can simplify that, and if I get 0, then this number goes in evenly. If it comes out to anything other than 0, there's going to be a remainder, and you saw it both ways by long division or synthetic division. So remember, if you have any questions about this, please come to class prepared to ask them.